Let's first take a look at the reciprocal identities. Alright, in your text there are only 3 that are listed, but there are also 3 others. I'll first list the ones that are in your text. Cosecant of theta equals 1 over sine of theta. Secant of theta equals 1 over cosine of theta. And cotangent of theta equals 1 over tangent of theta. Now the other 3 should be fairly obvious. If cosecant of theta is equal to 1 over sine of theta, that means that sine of theta is equal to 1 over cosecant of theta. So pretty much if you can list one of these, you can list the other, but they are very important in my opinion. Alright. Cosine of theta then would be equal to what? 1 over secant theta. And tangent theta would be equal to 1 over cotangent theta. Now, if I do ask you to list these, or if you ever have to list these, whether you're in this class or maybe even a higher level math class, make sure you don't just say cosecant equals 1 over sine, like write it down without the thetas. I've seen students do that in the past, and I mean, I understand that you're just trying to write it down faster, but the theta, the angle measure here, is important. And so you may be thinking, well, how can these identities be used? Well, in math, a lot of times we want to evaluate all the 6 trig functions at an angle measure. So think about any problems you've worked in here, whether it be on the homework or whether we work it in class, where we list out the values of all 6 trig functions, like at a quadrantal angle or at pi over 4. Well, we can use these identities, and if you just list, say, sine, cosine, and tangent of theta and what they're equal to. For example, when we were going over pi over 4, we said that we used the point square root of 2 over 2, square root of 2 over 2. Alright, so if I find the sine of pi over 4 by remembering that sine is the y coordinate, it is y divided by r, but the radius for an angle measure that corresponds to this point, that's on the unit circle, so the radius is 1. Alright, but the sine of pi over 4 is y, so it's square root of 2 over 2. The cosine of pi over 4 is x, again square root of 2 over 2. And the tangent of pi over 4 is 1. Okay? And so if we just write those 3 down, now we could apply the reciprocal identities and get the values for cosecant, secant, and cotangent. So cosecant is equal to 1 over sine. So what does that mean? That means that the cosecant of pi over 4 is equal to 1 over sine of pi over 4. And we just figured out the sine of pi over 4 is square root of 2 over 2. So that's 1 over square root of 2 over 2. And so you can flip and multiply, and you get 2 over square root of 2. And then after you rationalize, you'll get 2 square roots of 2 over 2, and these 2's cancel out. So what that tells you is the cosecant of pi over 4 is the square root of 2. Okay, it's just the reciprocal of what you get whenever you work out the sine. Alright, and so that means the secant of pi over 4 is the reciprocal of what you get when you work out the cosine. So if you take that reciprocal and rationalize, you'll get the same answer we just got, square root of 2. And the cotangent of pi over 4 is the reciprocal of what we get when we work out the tangent. So what is that? 1. And I know that you can look at the points and figure this out, but what if we were working a problem and because I think you'll have something like this on maybe your first test. What if you were working out a problem and you figured out in the problem that when you worked out the sine of theta, you got 1/3 as your answer. And maybe the problem wants to know what is the cosecant of theta. See, we don't even have to know the angle measure. If we know that the sine of theta is equal to 1/3, then the cosecant of theta is going to be equal to the reciprocal. So it would be equal to 3 over 1, or just 3. So that's how the reciprocal identities are very useful. Now, another thing that you need to get from these identities, and this is knowledge that you can carry on through calculus, because I still have students that make mistakes in calculus on what I'm about to show you. And you will use it in here as well. Alright, so like, if you have 1 over the sine of theta, and don't worry about the 1 on the top, anything over the sine of theta. If we wanted to write that and it not be a fraction, we wanted to write it as no denominator, then I know that you know what the reciprocal identity is equal to, but here's what some students try to do. If they wanted to take this sign and move it to the numerator, they'll say that's equal to sine of theta to the -1. And we don't want to think about it like that. The way that trig functions work, when you move them across the fraction bar, we're not changing the power. Okay? Whenever you move sine to the numerator, it becomes cosecant. So it becomes the other trig function, cosecant. Alright, so you don't want to think about it like that. You say, well, where would that be useful? Well, if you have to simplify a trig expression, which you will have to very soon in here, and say we had secant of theta times cosine of theta. Well, secant of theta, if you move it to the denominator, now there's no denominator here, but if you do move secant of theta to the denominator, you don't want to think about it like secant to the -1. When you move it to the denominator, you're going to say, okay, if I cross this fraction bar, it's going to change to its reciprocal. So that would be cosecant theta over cosecant theta. You see, and then that simplifies. That's just equal to 1. So when you move trig functions across the fraction bar, it's like you're applying the reciprocal identity.